Niels Bohr, a towering figure in both the world of science and philosophy. Known for his groundbreaking work in quantum mechanics, Bohr not only revolutionized physics, but also reshaped how we understand the very nature of reality. Born in 1885 in Copenhagen, Denmark, Niels Henrik David Bohr was destined for intellectual greatness. His father was a professor of physiology, and his mother came from a well-known and influential family. Bohr's early exposure to academia shaped his future in ways no one could have imagined. In 1903, Bohr began studying at the University of Copenhagen. Initially focusing on philosophy and mathematics, he soon turned his attention to physics. Under the guidance of Christian Christensen, Bohr developed a fascination with the atomic structure.
Niels Bohr wasn't just a physicist, he was a philosopher of science. His work was deeply influenced by the duality between theory and observation, and he continuously questioned how we can know and describe reality. At the heart of Bohr's philosophy was his principle of complementarity. He proposed that the wave and particle nature of electrons, for instance, were not contradictory, but complementary ways of understanding the same phenomenon. This was revolutionary. Bohr's philosophical discussions with Albert Einstein on the nature of quantum mechanics are legendary. While Einstein famously said, "God does not play dice," Bohr replied with a profound counter-argument, "Stop telling God what to do." This was the nature of Bohr's philosophical and scientific engagement, always challenging assumptions and breaking new ground.
Niels Bohr's most famous scientific contribution came in 1913 with his model of the atom. Building upon the work of Rutherford, Bohr introduced the idea of quantized energy levels, where electrons move in specific orbits around the nucleus. This model solved a fundamental problem in classical physics, explaining how atoms are stable and why they emit radiation only at certain frequencies. Bohr's theory introduced the concept of quantum jumps, electrons moving between energy levels by absorbing or emitting specific quanta of energy. His work laid the foundation for quantum mechanics, earning him the Nobel Prize in Physics in 1922. Bohr's contributions extended beyond just atomic theory. He became a central figure in the development of quantum mechanics, alongside scientists like Werner Heisenberg and Erwin Schrödinger. In 1920, Bohr founded the Institute for Theoretical Physics in Copenhagen, a hub for leading scientists to collaborate on the rapidly evolving field of quantum physics. This institute would become one of the most important centers for scientific research in the 20th century.
During World War II, Bohr played a complex role. Although a pacifist at heart, he was drawn into the race to develop atomic weapons as part of the Manhattan Project. Bohr made significant contributions to the understanding of nuclear fission and worked closely with scientists in both Britain and the United States. Yet, after the war, he strongly advocated for the peaceful use of nuclear energy and international cooperation to control atomic weapons. In 1950, Bohr wrote an open letter to the United Nations, urging world leaders to collaborate on nuclear technology for the betterment of humanity and prevent an arms race.
Niels Bohr's influence in quantum mechanics didn't end with his atomic model. One of his most profound contributions was the development of the Copenhagen Interpretation, a philosophical framework for understanding quantum mechanics. The Copenhagen Interpretation proposed that particles like electrons do not have definite positions or velocities until they are measured. Instead, their properties exist in a superposition of possibilities, represented by a probability wave. Bohr argued that observation plays a key role in determining physical reality. This idea, often summarized as the collapse of the wave function, suggests that particles can act as both waves and particles, depending on how we observe them. This revolutionary concept was central to how physicists began to think about the behavior of subatomic particles. Bohr's collaboration with Werner Heisenberg further solidified the Copenhagen interpretation. Together, they confronted one of quantum theory's most puzzling aspects: uncertainty. Heisenberg's uncertainty principle, that one cannot simultaneously know the exact position and momentum of a particle, complemented Bohr's ideas and became a core feature of quantum mechanics.
In his later years, Bohr remained intellectually active. Though no longer at the forefront of new quantum discoveries, he continued to engage with philosophical and scientific debates. His writings on the relationship between science and society deepened, and he became a public advocate for the social responsibility of scientists. Bohr's philosophy was always central to his thinking. He believed that science should not only advance knowledge, but also improve the human condition. This conviction drove much of his post-war work, as he campaigned for scientific openness and global peace. Bohr continued to mentor younger physicists and participated in conferences around the world. Even in his later years, his presence in the scientific community was significant. Bohr remained a key figure in the ongoing discussions about the ethical implications of scientific discovery. In 1962, at the age of 77, Niels Bohr passed away. His death marked the end of an era, but his influence on science and philosophy lives on. Bohr's work in quantum mechanics laid the foundation for much of modern physics, and his principles of complementarity continue to challenge how we understand the world. Today, Bohr's legacy is reflected in the technology that powers our modern world. From quantum computing to advances in nuclear energy, his insistence on the importance of dialogue, openness, and ethical responsibility still resonates with scientists and policymakers alike. Bohr's contributions to both science and philosophy have left an indelible mark on the world. His legacy reminds us that the pursuit of knowledge is not just about discovery, but also about how that knowledge is used for the benefit of humanity.
Today, Bohr's ideas continue to influence how we approach some of the most complex questions in physics. From the atomic model to quantum mechanics, and from philosophy to international diplomacy, Niels Bohr stands as a testament to the power of curiosity, collaboration, and creativity in the pursuit of knowledge.